next case study for discussion is this language. The set of x belonging to 0, 1 star such that or and x ends with 0, 1, 1. So if you look at the set, the simplest string or the base string is 0, 1, 1, and then followed by 0, 0, 1, 1 or 1, 0, 1, 1, then 0, 0, 0, 1, 1, then 0, 1, 0, 1, 1, and so on. Okay, so let's attempt to construct a deterministic finite automaton and subsequently a non-deterministic finite automaton, and then we ask can we design more than one mission, which one is minimum, and all such questions. Okay, so construction of DFA, NFA, then minimum DFA. So all this we shall answer. If you look at the set, you get to see it ends with 0, 1, 1, and the prefix can be any string over the set 0, 1. Okay. So the simplest automaton that one can think of, which will be a non-deterministic one, is the following. So this is any string over 0, 1. We know that this one tells you that it accepts any string over 0, 1. Correct? When you go over here, you can read epsilon and come back here, or read a 0, come back here, or 1, come back here, or 0 followed by 1, 1 followed by 0. So this part in some sense captures any string over 0, 1, 1, 0, 1. Then we have this pattern that it should end with 0, 1, 1. So for that we explicitly have this. I will make this one a final state. So that's all. So the simplest string is 0, 1, 1. Yes. And if you want to read a 0 followed by 0, 1, 1, then use this state to read a 0 followed by this. Or if you want to read 0, 1, then use this for 0, 1 and then do this. Okay. So now you see that this automaton, this part ensures any string over 0, 1 is taken care by this Q0 followed by this. Note that delta of Q0, 0 is moving to more than one state, which means this is non-deterministic mission, or this is an example of NFA. Fine. For the same language, one can also construct like this: Q0, 0, 1, then 0 followed by 1, this. Now what I do at this place, so I read a 0 and then loop on this. In case you read a 0 and couple of zeros here. After that you read 1 1, you will see that you still end with 0 1 1. For example, if the string is 4 zeros followed by 2 ones, for these three what you can do, for the first one you can read using this, for the next three you can use this followed by 1 1, or you can read the first three using Q naught followed by 0 1 1. So you have more than one way of accepting this using this design. Okay, this is again a non-deterministic machine accepting the language this. Okay. Now to complete this, now this is not complete. The reason is delta is a transition function from Q cross sigma to Q, right? And so there are transitions on this, for example Q2 comma 0, Q3 comma 0, Q3 comma 1, those things are left out. Fine. So one has to fill in those details. For example, let's start from this. With respect to Q naught, 0 is defined, 1 is defined. Although for 0 you are moving to more than 1, but it is well defined. But for Q1, 1 is defined, 0 is not defined. What I will do, when we read a 0, we go to some state, say Q4. And similarly, for this 1 is defined, 0 is not defined. Let me go to this. Similarly, for this 0 and 1 is not defined. For both, let me go over here. Now this is also a state. For this one has to define transition for 0 and 1. So let me do this. Delta of Q4 comma 0 as well as 1 is this. Okay, so on the similar line, this one says Q1 comma 0, we stay in Q1. 1 is also defined. So for this one, it does not. So what I do, when we read a 0, we come over here. For this, when we read a 0, we come over here. Then we stay at Q4 for 0 and 1. Okay. So remember, once you go to Q4, whatever you read or whatever you scan through, that will not be accepted by the automaton at all. Because final state is Q3 and you parse and then you go to Q4. Whatever you read at Q4, that will be rejected. Okay, that's one. And another one, because it is a non-deterministic mission, we may parse the same string in more than one ways, and one of them will take us to the final state, the other one need not. Okay, let's take an example and parse and see how the parsing happens for a given string. Okay. Let's look at this one, say 000 followed by 011. So this says you look at Q0, then Q0, then Q0. So for the first 0 it is Q0, then I read a second 0, stay at Q0, third 0, stay at Q0. Okay. Then what I do, when I read the fourth 0, I will go to Q1. Then for the next one, I will go to Q2. For the next one, I will go to Q3. Now, since it is a final state, I accept. But one can also parse like this. You simply stay at q naught for all of them, because it is a string over 0, 1. I can simply stay at q naught and read everything. Correct? Now input is exhausted, which means this branch says reject. But there exists at least one parsing that takes me from the start state to the final state for the string 000 followed by 0, 1, 1. If you find at least one parsing which is moving from q0 to q3, you say accept. Fine. So on the similar line, let's trace with respect to this example. So for this mission, so it's 000 followed by 011. One says you stay at q0 for all of them and reject. The other one says for the first 0 I read using q0. For the second one I go to q1. Then I read using q1. Then I go to q2 and q3. This says accept. There is one more transition that says q0, 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 then q1, q2, q3. This says accept. So now you see that you find more than one ways of parsing the input string, and one branch says reject and the other two says accept, and since there is at least one that says accept, you accept the string. Okay, so when you design non-deterministic mission for a given language, this is something one should make a note, that there exists at least one transition sequence of moves that takes us from the start state to one of the final states. Okay, so now a careful look at this will tell you that for each of them and for each symbol in sigma, the transition is well defined. Okay. So we were looking at this x belonging to this, and x ends with 0, 1, 1. If you look at the first state, it was having 0, 1, then followed by a 0, it was like this, and then transition on this, transition on this, all this was moving to q4, it was like this. One has to pay attention to the definition. Delta of q0, 0 was q0, q1. We said the transition function is from q cross sigma to q, which means you can only find something like delta of q0, say 0 is something like q0 or q1, exactly one state, because it is q. But what happens over here? Over here it is delta of q0, 0 as set of states, which is inconsistent with the definition. So there is a mismatch. So ideally delta of q naught comma 0 should go to some state, say q prime, where q prime belongs to this. It should be exactly one state, but it is like this. So which means if you look at q naught comma 0 and codomain as q naught, q1, q2 or that, then it says it is moving to q naught as well as q1. And it is clear that this is not a function at all. It is just a map. It is just a map from q cross sigma to q. Okay, but if you want to make it, so which means when you design non-deterministic finite automaton, we can't even call this one as a transition function. We can only say a transition map, because for some states, on reading a symbol from sigma, we may go to more than one state, which is inconsistent with the definition of function, so it is just a map. But if you want to talk about transition function in the context of non-deterministic mission, then we can fine-tune this part. So the transition function for non-deterministic finite automatons, since it is moving to more than one state, what is this q naught, q1 with respect to q? It is a substate. It is a subset, right? So q naught comma q1 is a subset of q. So what we will do, we will say codomain is 2 power q. What do you mean by 2 power q? Power set of q or set of all subsets of q, or power set of q. So which means on the domain we will have q naught comma 0, q naught comma 1, q1 comma 0, like this. Codomain we will have empty set containing q naught, then set containing q naught, q1, set containing q1, q2, like this, then set containing q naught, q1, q2, like this it goes. Now delta of q naught comma 0 is q naught, q1, then you see that it is mapped to this. Now it is a function, because when you read a symbol, you can go to subset of states. You choose that subset over here, which means each of them is mapped to exactly one subset, and by definition each one will have a map, will have an image. So this definition is true for deterministic missions or deterministic finite automaton, and for non-deterministic finite automaton, the transition function is from q cross sigma to 2 power q, so that what we define is consistent with the definition of functions. Okay, if you just work with this and then map, it is just a map, it is not a function at all. So q naught comma 0 can go to more than 1. So to ensure that we are consistent with the literature, what we do for non-deterministic mission, q cross sigma maps to 2 power q. So codomain contains set of all subsets or the power set, and this definition we use for deterministic mission, this definition we use for non-deterministic missions. Okay, so this is something you should make a note, and everything else remains the same. Start state, the final state part, all that. So now that we have designed two different NFAs for this, let's make an attempt in designing a deterministic mission for this language.